Hi, welcome to the Code-Dispenser channel. I'm Paul, and for those new to the channel, I've been working with Microsoft technologies since the mid-1990s and started using C# in 2003. The information within this video is applicable to all levels of experience, especially those coming from prior versions of Blazor. In my case, that was Blazor WebAssembly. I hope my pragmatic approach helps you to understand some of the issues with Blazor that you may face, saving you the time that I lost when I first looked at the .NET 8 Blazor offerings. Let's quickly discuss the options that we have after selecting the .NET 8 Blazor Web App template from the Create a New Project dialog. All options allow for an authentication type to be chosen that facilitates additional entries and items included within the project. For a client-side offline capable app reminiscent of the old hosted Blazor WebAssembly template, we can choose the WebAssembly option from the interactive render mode list, setting the interactivity location to global. This also gives us a familiar and consistent state management experience using a dependency injected scoped service. For a project similar to the old Blazor server, fully server-side with updates to the browser via SignalR WebSockets, we can choose the server option from the interactive render mode list, setting the interactivity location to global. This again allows for a familiar and consistent per user DI scoped service that we can use for per user state if required. Selecting the interactive render mode of none gives us non-interactive Razor pages fetched from and rendered on the server, with the interactivity location making no difference. Note that there are some significant differences with the location set to per page with interactive render modes, especially WebAssembly, that will be discussed later within the video. Although an interactive render mode of none is a non-interactive option, there are enhancements that come into play via the blazor.web JavaScript file, such as stream rendering and enhanced navigation, that make for a more pleasant and spa-like experience, and for some apps this might be enough. The interactive render mode of auto with the location of global gives us server interactivity using WebSockets and then WebAssembly interactivity when the WASM files have all been downloaded. Of all the options, this is personally my least preferred, but it may be perfect for your needs. I would suggest that the WebAssembly global template is a simpler option that should be considered first. It's worth mentioning at this point that all interactive options use pre-rendering by default, i.e. a request goes to the server renders the content and writes a response for the browser to display. If the component is marked as interactive WebAssembly, then after this pre-render, the whole page is re-rendered on the client and redisplayed. If the render mode is interactive server, then this re-render is again performed on the server, but this time it's done via an opened WebSocket. You can turn pre-rendering off for both global and per page options, as we will see shortly. Finally, the most tempting option is the interactive render mode of auto with the location set to per page, as this option gives us the ability to use whichever render mode we like on a per component basis. However, with this option, things can get complicated very quickly depending on your application requirements, and things may not work as you would expect them to. With regards to any per user state requirements that need to be shared across client and server, if you use interactive WebAssembly, interactive server and non-interactive components together, you will in effect have to deal with three separate applications in one and provide your own means of communicating that state. If you do not have any state requirements and do not need fully offline working capabilities, then this template option may give you some flexibility. Without getting too bogged down with details regarding both auto and server interactive components, WebSockets are opened, reused and closed per page, so what you had in the old Blazor server model with regards to a per user scope DI service no longer works. The WebSocket reuse can also be annoying. For example, a component marked as auto, despite its WebAssembly files being downloaded, will never run on the client while a WebSocket is open, and/or may flip-flop between running on the client and server depending on the navigation route taken. Let's first create a hosted interactive Blazor WebAssembly project using the location of global. I will also create a few other projects off camera for discussion. I believe there are 16 different combinations that we could choose, however the handful created should be enough for us to understand how things work. A GitHub repository with all of the individual solutions created is available to download using the link provided within the video description below. As you can see, we have two projects: the server that hosts the app.razor file, which is the root component containing the HTML document structure, and the client project that contains the files to be downloaded to the client. You should note that the app.razor file houses the roots component responsible for routing. Of the utmost importance in your understanding is this often overlooked piece of information. Child components inherit the render mode of their parent unless the parent does not have its render mode set, in which case they can have their own render mode value. This relationship extends from the topmost parent all the way down the hierarchy. Although not technically correct, I find it easier to think of the router as being the parent for all other components excluding the head outlet, as if a render mode is set on the router, then that is what is in effect for all components and it cannot be overridden. If the router does not have a render mode set, then every component, unless provided with an interactive render mode, is effectively a non-interactive component. One thing I often hear is other developers stating that layouts are not interactive. This is not completely accurate. In our case, the main layout could have clickable buttons on it with associated event handlers, as it inherits the interactive WebAssembly mode from its parent. If the root component did not have its render mode set, then the main layout would not be interactive, and the interactivity would have to come from its children. Let's take a look at how pre-rendering works. There are a couple of ways we can do this, but using breakpoints is sufficient and allows us to see exactly what is happening. When a pre-render occurs on the server, it does not fire the usual on-after-render event after the uninitialized event, normally associated with the interactive component event lifecycle. Given this, we can logically expect that when we make a request to the server will pre-render the component and write the output ready for the browser, but without firing the on-after-render event. The page should then be displayed in the browser with the WASM files being downloaded in the background. Once all the files are on the client, the program file main method should then run. We will use the home page for testing our expectations, and we are expecting to see that the uninitialized event is fired twice, but only once for the on-after event. As this is interactive WebAssembly set globally, this pre-render will only happen once for the home page unless the browser page is refreshed. If we had set the project interactivity location to per page, then the home page would pre-render on the server every time it was requested, despite it being a WebAssembly project with all the WASM files on the client. As a side note, a pre-render of an interactive page or component is just like the fetch of a non-interactive or static page, also termed SSR, static server-side rendering, as they too do not use the on-after-render event. Let's add the events without the breakpoints and run the application. I prefer to use IIS Express. I will change the setting to use that before running the app. Let's open the DevTools and change the options so it does not set focus to the Sources tab every time we do something, which I find extremely annoying. Now that's done, let's go back and set the breakpoints within the home page and add another inside the program file so we can see the order in which things occur. Despite these breakpoints, I am also going to slow things down slightly by using the network options and throttling the bandwidth to that of a fast 4G connection. Whilst in the DevTools, it is also important to delete any downloaded WASM files, as well as to do a hard refresh so as not to get skewed results due to any caching. We can do this from within the Applications tab, deleting the .NET resources from cache storage. Once deleted, we can right-click on the browser's refresh button and choose the empty cache and hard reload option. Despite the menu name, it does not delete the WASM files. The oninitialized event breakpoint is first hit server side. Let's continue. We should see the page in the browser without the onAfterRender event breakpoint being hit. The WASM files are downloaded in the background, followed by hitting the client-side program file breakpoint after the download completed. Let's continue on. The home page oninitialized event breakpoint is hit again, this time followed by the onAfterRender event, with the re-rendered page updating the browser. As a side note, do not forget that if the home page had any interactive items, such as buttons, these pre-rendered versions are not interactive until run on the client. One way of preventing any confusion amongst users with really slow connections would be to disable buttons and enable them from within the onAfterRender event. Let's clear the display of the captured network files and navigate to the weather page and then back to the home page. We should just hit the oninitialized event breakpoint, immediately followed by hitting the onAfterRender event breakpoint, with no requests made to the server. Let's now look at what happens if we do not use a global pre-render. To negate any issues with hot reload, we will first close the browser and change the app so it does not use pre-rendering. In order to change the global pre-render value, we need to set the router component's render mode attribute to use a new instance of the interactive WebAssembly render mode class with the constructor parameter value for pre-rendering set to false. This is opposed to just using the static interactive WebAssembly value. Let's clear the breakpoints to avoid hitting them, run the app, re-add the breakpoints and clear the WASM files as before. As you can see, this time around there is no pre-render and we are staring at a blank browser page whilst we wait for the WASM files to be downloaded and the program file run. The breakpoint in the program file is then hit, and after continuing, both the oninitialized event and onAfterRender event breakpoints are then hit. Before we move on to the next project, let's quickly look at the server-side program file, as that is where things get wired up to give us the ability to use the various render modes. On line 14 you can see the Add Interactive WebAssembly components being added, and then on line 36 the Add Interactive WebAssembly render mode being assigned to allow for the support of WebAssembly interactivity. It's then followed by the addition of any additional assemblies, as you can see on line 37. Let's close this solution and move on to the Blazor Server Global solution that I created off camera. All the solutions have names that indicate the interactivity render mode and interactivity location. We are now looking at the home page of the interactive server project that was set with the interactivity location of global. I have completed the preliminary work as before, adding the events 4 breakpoints and tweaking some of the DevTools settings. I have also reduced the network throttle level to the slowest, so it takes more time to send a request to the server and for it to return the pre-rendered page. On the right you can see that this time there is only a single server project housing the files. Let's run it, add the breakpoints, clear the cache, reload the app and observe the results. The uninitialized event breakpoint is hit. Let's hit continue. As there is no on-after render event with a pre-render, the output is displayed in the browser. You should have noticed a flicker as the current display was replaced with the reloaded pre-rendered version. After a couple of seconds, we should see the WebSocket entries in the DevTools, followed by our homepage uninitialized event breakpoint being hit as it starts the re-render on the server via the WebSocket. We press continue and the on-after render event breakpoint is immediately hit. Finally, the browser page is updated. If we now navigate away and back to the home page, there is no pre-render as indicated by the on-after render event breakpoint being hit immediately after the uninitialized event breakpoint. Let's take a quick look at the app Blazor and program files before moving on to the next project. The overall layout is the same, but this time the root's component render mode attribute is set to interactive server. This project acts in a similar fashion to the global WebAssembly project, and if we were to disable the global pre-render as before, we would again be left looking at a blank screen whilst the WebSockets are opened and the page re-rendered on the server via the WebSocket. The program file is also similar as before, with server components and server render modes being added instead of WebAssembly values, omitting the unnecessary additional client assembly entry. Let's close this solution and move on to the next, the Blazor Auto Global solution. As usual, we are starting on the home page. I have not added any breakpoints to show pre-rendering, as we have already seen how this works for both WebAssembly Global and Server Global, and Auto is just both of them, once in server mode when the app is first requested, and then in WebAssembly mode on subsequent visits. You may have noticed that I have added a line of code that sets a variable called location to the value of either on the client or on the server. This value is dependent on the result of the call to the isBrowser method of the system namespace operating system class. This method returns true when WASM is running in the browser. I have also added this code to both the counter and weather page components. Let's run the application and navigate between the pages. Initially, the app runs like Server Global until all the WASM files have been downloaded and there are no active WebSockets open, after which the components will run as WebAssembly Global. This is generally after you have left the application and then returned to it. Let's copy the counter URL, navigate away, use the copied URL to return to the counter page directly, and observe the execution location of the components. You should have noticed that for a brief moment the location of the counter page says on the server. This is due to the result of the pre-render prior to the counter executing on the client and resetting the location variable. Let's open the DevTools, navigate between pages to ensure that all components are now running on the client. There should be no entries appearing in the DevTools. If we take a quick look at the app Blazor file, we can see that the root component's render mode attribute is set to the interactive auto static value, which has the pre-render value of true, which matched what we've just seen. Looking at the server project's program file, we can see that the template has added all of the necessary entries to allow for both execution on the server and on the client, as indicated by the code on lines 14, 15, 37, 38 and line 39. Earlier I stated that Auto Global is my least preferred choice of the Blazor templates. I should explain why that is so as not to deter you from looking at it. My rationale stems from my pre.NET 8 Blazor WebAssembly projects. In auto modes, components can run on both the server and client. Components when on the client may need to access data accessible on the server and as such may need to use injected services to call a web API or a gRPC service hosted on the server. Such components expect the injected service to be accessible, irrespective of whether it is on the client or server, and as such the required service needs to be available on both the client and server. It is also very likely that the code in the service would need to be different for each location. This is a simple problem to fix. You just create another project for any service contract interfaces, referencing the project from both the client and server projects. The appropriate implementations can then be created and registered in the respective project's dependency injection container. My last Blazor WASM project had 12 main data service classes on the client, each with about 15 methods making remote procedural calls using gRPC, so approximately 180 methods that I wrote tests for. Using auto global, given I would not know which component would run in server mode, I would need to create 12 interfaces, 24 implementations and write 360 test cases. I would also have the complexity of trying to manage state across the two modes if it switched before the user left and came back. For the majority of my applications and how I structure them, I would not gain any benefit from using this template. However, it may be perfect for your apps. It should also be noted that the problem just described can also occur with pre-rendering. If your component uses an injected service within the onInitialized event, then that same service would also need to be available on the server during the pre-render. That is all I wanted to cover on Interactive Auto set globally, so let's close the solution and move on to the next. I have included the following project: Blazor WASM Global Auth, an interactive WebAssembly project with the location set to global, but including the authentication template pages as a segue to the last project, Interactive Auto, with the location of per page. It is not my intention to discuss authentication within this video, only to show you how this template dynamically switches between global interactive WebAssembly and static render modes. If you look at the server project files on the right, you can see that there is now an accounts folder. This folder and its subfolders contain many static pages, including the register page that we shall be navigating to shortly. For those who may download the GitHub repo, it should be noted that I have not applied any migrations or created the accounts database. So if you did run the app and try to register a user, you should be prompted to apply the migrations and confirm registration as the project template normally does. Before we run the app, let's look at the app Razor file to see how it differs from the Blazor WASM Global project, considering it now has menu items in order to navigate to the static account related pages on the server. We can see that the render mode is dynamically changed depending on the route. If the request path starts with accounts subsequent to the base URL, a variable of type iComponentRenderMode is set to null. Otherwise it uses the familiar interactive WebAssembly static value that uses pre-rendering by default. When there is no render mode set, Blazor will make a HTTP request using the request path, and as such the app Razor file is run on each request. When using an interactive mode, Blazor uses the URL shown in the address bar to determine which components to render. Let us run the app, add breakpoints to both the client program file and to the app Razor file's onInitialize event that I have already added. Let's open the DevTools before navigating between the client-side pages. So far so good, as there are no fetchers being displayed. Let's set the network throttle to offline to ensure that we can navigate between client pages when completely offline. We need to re-enable the connection before we can navigate to the static server-side register page. As expected, the app Razor file's onInitialized event breakpoint is hit, as Blazor has used the HTTP request path, and an entry for the register page is displayed within the DevTools. When we navigate back from this static server page to a client-side page, the breakpoint within the app Razor file is hit again as it is reloaded, followed by the breakpoint within the client-side program file's main method as it is rerun. I was stunned the first time I saw this, and can advise that this is not a bug. I did raise this and other concerns with the Blazor team via the issues section on their GitHub repo, asking simply if these were by design or bugs. The response I got back was that they were by design. Having the program file run after logging into an application is not an issue, but if you wanted an offline capable app with the odd call to a server-side static page for whatever reason, is rerunning the program file's main method and all the code that may be within it acceptable to you? Only your requirements can answer that question, but just remember that you will lose any state that has not been saved to a location, such as browser session or local storage, every time you navigate to the server-side static pages and back again. Let's close this solution and move on to our last, the interactive auto with the location set to per page, which is a template that gives us the most flexibility but potentially the most headaches if per user state must be synchronized across differing render modes and locations. All of the interactive render mode project types that use the location of per page all operate in a similar manner, with the root component's render mode attribute unassigned. Without a render mode set on the router, by default all components are non-interactive using static server-side rendering until assigned a render mode. As already discussed, without a render mode set on the root component, when navigating between pages a request will be made to the server, even if that page is interactive WebAssembly and already available on the client. So despite an interactive WebAssembly component having the ability to be interactive when offline, you will be unable to navigate between pages without an active network connection. Our current project is using interactive auto with the location set per page. If we look at the server-side program file, we can see it has all the settings to allow for either server or WebAssembly interactivity. Basically, as this template has all the settings applied, you are free to use whichever interactive or non-interactive render mode that best suits your needs. By default, the template used provides one simple interactive component, a counter page within the client project. This page has its render mode directive set to the static interactive auto value, so it will use pre-rendering by default. I have changed its name from counter to counter auto to easily differentiate it from the copies that I have made. We now have three counter pages: counter auto, counter server and counter WASM, their names indicating their type. Counter WASM and server have had pre-rendering disabled. Let's look at these two before we start the application. For the counter WASM component, I have turned off the pre-render value by using the razor syntax and setting the render mode directive to a new instance of the interactive WebAssembly render mode, passing false for the constructor argument. For the counter server component, I have set the render mode attribute to a static variable. This could have been set in a utility class and reused for all server components that you did not want pre-rendering on. The same approach could be used for other render types. You may have also noticed that I have added the location variable shown in other projects to all components within the solution, so we can see where any component is finally executed. Let's start the application and navigate to the counter server page. Now let's navigate to the counter auto page, which should run on the client if the WASM files are available, otherwise it should run on the server via a WebSocket. The location is showing on the server, so perhaps the WASM files were not available. This was not the case. Despite any expectations, Blazor will use an existing WebSocket connection if available, even when the WASM files are ready for use on the client. Let's navigate to the counter WASM page to prove that the WASM files had been downloaded but not yet run. You may have briefly seen the blank area where the counter content goes. This was due to us disabling pre-render and the time taken for the program file's main method to be run, followed by the loading of the client-side counter page. Going back to the counter auto page, we can see it is now running on the client. However, if we now navigate to the counter server page and then back to the counter auto page, As the WebSocket is still open, Blazor runs the counter auto page on the server via the WebSocket instead of on the client. Some may argue that the project is interactive auto, and as such I have artificially created the problem by using server components, which is a fair point. However, if the connection is slower than required, your first interactive component may be used before the WASM files are ready, and as such will run server side. At this point, unless you have a static page that you can navigate to, allowing the WebSockets to close, you will be stuck running the components on the server until your next visit. Another point I should make is that you may want to use server-side components for some parts of your application for additional data security. And as I initially stated, this project template does provide flexibility, but with caveats that in my opinion should be understood. To finish off this project demo, let's navigate back to the counter WASM page, ensure it still works correctly, open the DevTools and turn off our connection. The counter page continues to work, however, we cannot navigate to any page, even pages that are already on the client, nor can we use the browser's back and forward buttons to show cached content. In conclusion, and to share my opinion to those that may be asking which project template should be used, obviously everybody's requirements will be different, so I can only share my thoughts and opinions. I generally only consider 3 project types: Interactive WebAssembly Global, Interactive Server Global, and Interactive Auto per page. My reasoning, which you may or may not agree with, which is totally fine, is as follows. For most line of business applications used by organisations, if the organisation had end users with low spec devices, outdated browsers, or had higher data security needs, then I would look more closely at Interactive Server. If network connectivity was an issue, requiring a better disconnected experience, or more processing was possible on the client to reduce server load, or a higher level responsiveness was required, then I would favour Interactive WebAssembly. For other web applications, I would look at Interactive Auto with the per page model, using whichever render mode was applicable for the task at hand. It is doubtful that I will ever use WebAssembly per page, given that you cannot navigate offline, just for the ability to turn off pre-rendering on a per component basis. With regards to the Interactive Server template using the per page model, I cannot even think of a use case for it. Interactive Auto Global just seems like more work when I could just use WebAssembly Global with less headaches. If I required a static site, I would just use Interactive Auto per page without adding interactive components. WASM is not downloaded if there are no components that require it. This template allows for the addition of interactivity if required without alteration. You may have found my rationale somewhat basic. That's okay. It's just what I use, but I do hope the demos and discussions help you in some way. Finally, if you did find this video helpful, then please consider supporting the channel by subscribing or buying me a coffee using the coffee link in the description below. I do have a list of videos that I would like to create regarding Blazor, C# and SQL Server, so any support or encouragement is welcomed. At some stage I will buy a proper microphone instead of just using the one on my webcam. This video was twice as long as I had planned, so thanks for watching it to its conclusion. Until next time, bye for now.